So we're here today to talk about powers of monomials. Monomials, again, were those things from before where you have variables and constants all multiplied together. In other words, monomials are single terms, not polynomials, but single things that are being added and subtracted. Well, what we are faced with here is a little bit of warm-up. Okay, let's just kind of go through these. And you can copy these down and pause the video and kind of work through these yourself, because that might be more valuable. Where I see this as being helpful is in understanding what all this means. Negative 2 to the third power. Negative 2 times negative 2 times negative 2 is negative 8. Negative 3 to the fourth power is the same thing as 9 times 9, 81. Since it's to the fourth power, we get rid of the negative. Negative a to the sixth power, well, the negative to the sixth power is just a positive. This is just the same as a to the sixth. But a negative b to the fifth power is the same as negative b to the fifth power, written without the parentheses because it's going to be negative. Number 5, I'm looking for what the question mark is. What times 7 to the fifth is 7 to the eighth, and that what would be equal to 3. Same thing here, that what would be equal to 6, n to the 10th times n to the 6th is n to the 16th. Number 7 is saying 2 to the 4th times x to the 3rd times 2 to the what times x. Well, all we have to do is just look at the two parts and realize that that question mark needs to be a 5. Then number 8 is saying x to the 5 times 2, that's really 5 times 2, is the same as x to the 5 plus what, which is the same as x to the 5 times x to that same what. And that what would have to be a 5, pretty much because 5 times 2 is the same as 5 plus 5. Okay, now let's do some ones that are a little bit more applicable to this section. We start with number 1. We have m to the third power raised to the 4th. I'm going to do two of these at the same time, so let's write all these down. Then we'll have x to the second power and raised to the 5th. And I'm going to do, let's keep them all the same, negative b after two parentheses to the 4th, and then to the 5th. And then finally, 2y to the 4th power. Well, if you look at these, the first one's the power of powers rule. If I raise a power to another power, if I have m to the third 4 times, that's the same as m to the third, m to the third, m to the third, m to the third. And that is going to be m to the 3 plus 3 plus 3 plus 3, or m to the 12th. 2, we are going to have x to the second 5 times, and that 5 times is going to give us 5 times 2. X to the 10th. Number 3, if I go order of operations and work my way from the inside out, that negative b to the 4th is just going to be positive b to the 4th. But then raised to the 5th power, that means we're going to have b to the 4th 5 times. 5 times 4, b to the 20th. And finally, this is going to give us 2y times itself 4 times. 2 times 2 times 2 times 2, that's the same thing as 2 to the 4th, and then y to the 4th. And 2 to the 4th we can simplify to 16. So that's 16y to the 4th. So the rule is, for all positive integers, m and n, a base a raised to the m power and then raised to the n power, so it's raised to 2 powers, and I call this power of powers. Something raised and then raise it again. That's the same thing as a to the m times n, or a to the mn. Power of powers means you multiply the exponents. That's going to be a theme that we emphasize throughout this chapter. So for all positive integers, a to the mn is equal to a to the m times n. Second rule, for every positive integer m, if I have two bases, a, b raised to the m, that is the same thing as a to the m, b to the m. You may think of that as kind of like a distributive property, but I do not want you ever to use those words. You can never use the words distributive property unless you're talking about multiplication across plus or minus. There is only one distributive property. There will only be one distributive property, and that is multiplication across plus or minus, or division across plus or minus. This is not a distributive property. Notice how I did not say a plus b to the m is equal to a to the m plus b to the m, because that is not true. We proved that in the very first part of this chapter when I talked about proof by counter example. That was this thing. This is not true. This is true. This is good. This is bad. So let's kind of do some examples of this. With number 5, what I see is negative 4mn all to the third power. How many things are we raising to the third power? I actually count 4. I would say we have a negative 1 to the third power, and then a 4 to the third power, and then an m to the third power, and then an n to the third power. It is insanely ridiculous to write it out like that, but because these are notes and I can get away with it, I'm going to do it. Negative 1 to the third power is negative 1. 4 to the third power is 4 times 4 times 4. You're going to get in the practice of that. That is 64. M to the third, n to the third. You should be able to go directly from here to here and get this as your final simplified answer. Number 6, negative 2 to the 5th power. When I raise negative 2 to the 5th, I know it's going to be negative. I know 2 to the 5th is 2 times 2 times 2. I'm just going to write it like that right now. K squared to the 5th power is a power of powers. That is not k to the 7th, that is k to the 10th. When we raise powers to other powers, we multiply them. So I'm actually going to write this now as 2 times 5, so I can show work, and then we're going to make the next step be negative 32, k to the 10th. Number 7, that negative 2 is a coefficient. It is not being raised to the 5th power, so that's going to stay as a negative 2. But then the k squared is negative 2k to the 10th. Let's circle all these. Number 8, do not multiply these yet. You'd be breaking order of operations. We have to deal with the exponents, so we're going to make this a little bit messier at first. 2 to the 4th, x to the 8th, y to the 12th. A negative squared is a positive, so that negative goes away. X to the 2nd, remember that's really x to the 1st, and we multiply when we raise powers of powers, so that's x to the 2nd, y to the 4th. So basically I multiplied the outside power into all the inside powers. And you've got to remember that those numbers like 2 have an exponent of 1. So if you see any constants or any variables that don't have an exponent, they really have an exponent of 1, and then that exponent gets raised to all of them. So now I have to clean this up. Cleanup works like this. Let's look at the constant. 2 to the 4th. 2 to the 4th is 16. Let's look at the x's. X to the 8th, x to the 2nd. You may be tempted now to say x to the 16th because you've been doing that, but now we're back to the first rule, saying when we multiply two bases with this, or two exponents with the same base, we add the exponents. X to the 10th. And then y to the 12th, y to the 4th, y to the 16th. Flip your page over. Uh-oh, fractions. Not a big deal. 1/10 to the 3rd power is actually the same as 1 to the 3rd power over 10 to the 3rd power. It's the same rule with multiplication as it is with division. X to the 9th, y to the 3rd, times 10 to the 4th, then y to the 4th. Okay. 1 to the 3rd power is 1. 1 raised to any exponent is 1. 10 to the 3rd and 10 to the 4th are interesting. 10 to the 4th is going to be, well, let's see what happens when we have something like x to the 5th over x squared. When we have something like that, when we divide with the same base, we subtract the exponents. That rule is coming. For right now, let's multiply this all out and see what happens. I'm going to kind of erase this, just get that out of the way. So let's clean this up. We're going to go 1 over 10 to the 3rd power is 1, 0, 0, 0. Then I have, let's combine our x's. There's just one x, x to the 9th. Y to the 7th and then I still have that times 10 to the fourth is a 1 followed by 4 zeros. These are going to cancel and give us 10. So my final answer is 10, x to the 9th, y to the 7th. Number 10, we're going to follow order of operations. Can't do anything in the groups, but I can raise those groups to exponents. 2 to the 3rd, x to the 3rd, then x to the 2nd, y to the 2nd, plus, keep raising, don't multiply yet, so we're going to raise 2 to the 2nd, x to the 2nd, y to the 2nd, and then a negative to the 3rd power is going to be a negative, so it's times negative, and x to the 3rd. Now, there's still kind of a grouping symbol going on here because I can simplify that a little bit more. So let's clean up both of these. By clean up, I mean let's just combine stuff. So we got 2 to the 3rd is 8, x to the 3rd, x to the 2nd. That's a common one that people screw up. X to the 3rd times x to the 2nd, you add them. But x to the 3rd to the 2nd, you raise them. This first one is x to the 5th, but the second one is x to the 6th. The one in the problem is x to the 5th because they're two exponents, same base, add exponents. Then we have y to the 3rd. This is now a minus because of this negative in front of the x cubed. So minus 2 squared is 8. X to the 2nd. X to the 5th because we have x to the 2nd, x to the 3rd, and y to the 2nd. 4x to the 5th, y squared when we add our like terms, and we're done. Our next one, we have to follow order of operations again. 2 to the 3rd power, x to the 6th, or x to the 3rd, then x squared, y squared, times 2 squared, x squared, y squared, and then negative x to the 3rd. You may say, this is exactly the same thing as the one that came before. Sorry, that negative x to the 3rd should go in parentheses. But it's not because there's a times there. That actually changes everything when we get down to it, because now it really doesn't matter what order we move stuff around. I could start combining stuff, but I might as well do it all at the same time. 2 to the 3rd and 2 squared are actually 2 to the 5th. X to the 3rd, x squared, another x squared, and x to the 3rd. We add up all those exponents, 3 plus 2, plus 2, plus 3, we have an x to the 10th. And that negative has to now come out in front as part of the coefficient. Y to the 2nd, times y to the 2nd is y to the 4th. And then I have negative 32, x to the 10th, y to the 4th. Number 12. All you have to think is power of powers, which means raise exponents, multiply them. That's a to the 3x. And that's it. That's all you can do with that one. Number 13, power of powers, but don't forget the 4. It's really 4 to the 1. So this becomes 4 to the 3rd, x to the 3n, and then x to the 5n. 4 to the 3rd is 64. X to the 3n and x to the 5n. It's actually x to the 3n plus 5n, or 64, x to the 8n. Number 14, power of powers gives it t to the mn. Then I have times 3, t to the mn. So this can be a little confusing about what you do here. I have 3 t to the, and I actually add these, mn plus mn. And I have 3t to the 2mn. Number 15, 3 squared, c squared, m to the 6th, times, and when I carry this one in, I have negative 3 cubed. So this time I'm going to do something a little different. Because negative 3 is going to be, or cubed is going to be a negative, I'm going to stick that negative out front so I don't have to worry about things looking weird. And then 3 cubed is 27. Or, you know what, I can just write it as 3 cubed right now. That might be a little bit better in combining it with the rest of it. I don't know, you can do it however you want with that. C to the 6th, m to the 12th. Then I have negative 3 cubed and 3 squared. This is why I kept it like that. 3 to the 5th, c to the 8th, m to the 18th. 3 to the 5th is 243, so I have negative 243, c to the 8th, m to the 18th. Number 16, 1/2 squared. 1/2 times 1/2 is 1/4. You can also think about that as 1 squared over 2 squared. Y to the 6th, 2 to the 5th, y to the 5th. Well, now if we make it 1/4, combine your y's and you have y to the 11th, and 2 to the 5th is 32, so I'm just going to put it times 32. Let's do the 1/4 times 32. 1/4 of 32 is 8, so this ends up being 8y to the 11th. Finally, number 17, 3 cubed, a to the 6th, b to the 3rd, then I have a 2, a cubed, b. 3 cubed is 27, 3 cubed is not 9, don't ever make 3 cubed be 9. 3 cubed is 27, 27 times 2 is 54, a to the 6th and a to the 3rd, you add the exponents to get a to the 9th, b to the 3rd and b gives us b to the 4th. And we're done.